Let me start again with the same point, but in a little faster way. Earlier, what we are saying that we define our data, and as per the data with the values of 1 and 0, we are expecting that we are not going with the linear model. And so we decided to choose some other model, which might be better from this. So as per the condition, if you are saying so observation because 0, 1 say the same per the plot, which is your function, which is defined by better way is a sigmoid function. And it is a complete family of sigmoid function, and out of which we are just considering a particular one. So here we just say if it is, we are just take the basic one, the sigma x is equal to 1 upon 1 minus c raised to the power minus x. Otherwise, we can go with some more generalized form when we are considering a and b. And additionally, for that value of a and b, we are just that value of a and b. What we have done, we just plot this. Here it is, of course, we are just saying that with the value of a and b, this plot will be somehow shifted from one point to another point. So if you are just considering, say, 1 is equal to this, then this plot will be just shifted from, say, over to 0. Okay, so these are the different values, and we are just assigning as per find out. So somehow, if a particular form of plot is given to that data, the data we just consider with the values of 0, 1. So out of, say, infinite number of, say, such plots, infinite number of plots, the plots we are considering here. So this particular plot, say this, there is a possibility of, say, infinite number of, say, S-shaped curve that can be we can sketch, but overall purpose is to find out the unique one, the particular one, which one is the best. Okay, so that is the methodology we are trying to find out. Of course, we just go with the MLU. But before that, one more thing that we just, it will take not more than 2 minutes. What will happen if, say, this particular function we are just plotting here, we just go with one more variable. One more variable in the sense here we are considering, say, on the x-axis, say, one variable, say s1 or x, and on the y-axis our function. But if we have one more variable, means we are adding one more dimension in this. So what will be, say, either we just analyze this or let do in the next. So we just define S1 as it is, then we are using the another one, say S2 in the form of this, another sequence. And this sequence can take, say, values from S2 again, from minus 10 to 10, or you can take any other values. Then what we are defining AA and, say, B1, which is associated with the first variable, and, say, B2 as assigned with, say, some value 5 for the another variable. Okay. So now actually our model is like earlier we defined, say, e raised to the power minus a minus bx1. Now we are saying it is minus a minus b1x1 minus b2x2. So one more dimension, one more variable, independent variable we are assigning. So of course, in this case, if you're just trying to visualize, in that case, on one axis there will be x1, on the another axis there will be x2. And then on the third dimension, there will be your actual S function. So point is, if that the thing what I'm saying earlier, if once you just visualize your function, then it is quite easy for all the time to fit that model. You can actually, before computing the thing, before calculating the thing, you can see actually what is going to happen with your with the data. So point is, what we have done, say, we just define this. So in better of this, we are defining, say, here s dot, say, f1, I just said it to this, and you can define a function in better form is, say, function is function of what, if this will be a function of s1 and s2, and for that function we are just putting the whole expression within that. Okay, for this value of this, we will try to find out the values of s1, and even though you can just define this in particular, so it will be easy to understand. So what we are saying, say, here it is, say, minus of this, say, minus of b1 actually, and minus of, say, this. So here we are saying, so this will be 2 and this will also be 2. So this will be our function which we are interested to calculate. Say we are showing s dot f1. and there is no purpose of this. Either you can delete this. So overall, we just define two variables, S1, S2, and accordingly we define three parameters. Now your one dimension is increasing. So we are calculating, we are putting the values of A, B1, and B2, and then our function will be defined as 1 divided by 1 plus exponential e raised to the power minus of A minus of say B1 x1 minus of B2 x2. So here it is BB1 into S1 minus BB2 S2. So this is the functional form. So in case, as you know, that this will be a three-dimensional plot. So first of all, I think you must calculate a function, say outer function in this case. Say outer function is, you can define this, earlier we just take S dot F. So say Z dot F, I just copy this, is equal to, I think it must work, outer, and it will consider the values of S1 and the S2, and then your functional form S dot F1. Okay. So I think it will work. S2 not fine. First we have to run this, and then lastly Z. So Z is our outer function. If we try to understand the outer function, that outer function is something which gives the values of your function for each value of x to the each value of y. So it provide a kind of matrix. Okay. So what we have on the in the say like header in the column, we have one vector, say S1. On the rows we have another vector S2. Then for each value of S1 and S2, we are getting a value of this function S total. And if I'm not wrong, then percep is the, I think, command. It's at the perspective. Don't think that it need any particular, what we will say, package for particular this. Let's see it will run or not. S1, S2, and at the same time we are taking Z dot. This is our outer. It may take some time. Okay, percep is working. Then why it did not float? Okay, now good. It will take a little time. We have to consider actually the bigger sequence. You can keep the sequence little lower side to see the plot. We just take this, say 1, 1. So now it will calculate quite easily. And percep is of course a three dimension. There are some two parameters. I think theta is something, so around 5 is another variable. It's considered as 30. There are two way. Okay, now it is looking better. And I think we can turn this. So see how it will look now. 60 is better. You went for say 45 for this. No. You can see, or you can just take. Okay, good. So here it is looking like this. So this is your function. You can move this accordingly. So it's still, the point is, what my point is, once you are adding one more variable in the same data, earlier we are just taking that there is a variable, maybe calculate counts or anything else. It's a single x variable, and accordingly we are finding the value of y. Okay, the response variable, which is of course 0 or 1. But the point is, there is a possibility that there may be more than one variable at the same time, independent variables. So there may be x1, x2, x3, and in that way. So here we are considering, in first case, when we are plotting simply s1 versus this s dot first plot, in that plot we have a simple plot. Okay. In that plot, things are like one-dimensional. We are not doing with this. The point is, things are just, it is a simple plane, a two-dimensional plane where one variable x is defined, and accordingly you are getting the value of 1 and 0. But if there are more than one variable, on the behalf of that you are defining, say at the same time with the, say as per we are considering our data, you can take the platelets at the same time, some other factors, maybe hemoglobin or maybe cholesterol level, what depend upon things. The point is, the variable, even age may be a factor, or gender may be a factor. So there may be a number of variables, then those can also associate with your response variable. So in that case, you have to add those variables to define your model in better way. So the overall point thing is the sigmoid function can be capable to capture all those things. So what we have done, we just increase S1 is already defined, S2 in new variable like X2, and then accordingly we need three parameters, say A, B1 and B2, and then our function will be defined with, and the overall function will be defined like this: 1 by 1 plus exponential of minus of A minus of B1 x1 and minus of B2 x2, like things. And then accordingly we just calculate what will be the value as per the outer function. And then lastly, this is our function will be look like. The overall purpose to show that this particular plot is that even though it is three-dimensional plot, even though the shape ph and theta, okay, Shahas Patel, good. The point is theta and phi is actually the angles we utilize to how we will visualize this plot. At what angle, these angles, these directions, to define the direction. Say if I just change, I think it is the theta function change, it is horizontally. So if we just say 60, so it will be shift, it will be moved in horizontal way. So that is why theta is defined. And to change this vertically, we will, okay, so this is kind of rotation at which particular angle is good to see your plot actual characteristics, okay. Or sometimes if you are interested to put, say, there's that kind of plot in your presentation or say in your article in some time, so in that case you need some kind of a best view from that we can get maximum information from your plot or from your data. So that's why you have to find out the fixed value of theta and phi. It will depend up to your data and your plot. So I think earlier we take 60 and 30. Like here we are just finding the 60 and 30 is a good choice, or 50 is I think good choice. Okay. So my purpose is, I think it is clear, Patel? Yes. My point is the shape of this curve, shape of this sigmoid function, this particular function is still same. Still it is looking like a S-shaped curve. Number one. And number two, is still on the y-axis or in the third dimension, the response variable is 1 and 0. Okay, there is no changes on the y is still 1 and 0. Doesn't matter, it is kind of multivariate. Earlier you considered only x1, now you are considering x2 as well. You can consider x3, x4, x5, but response variable will be either 1 or 0 at the same time. And overall in general, the shape will be S. Okay, still we can say it is looking like S. So if it is in 3-dimension or 4-dimension, we cannot visualize, even we cannot design in the R. But the point is the overall in general form of the shape will never going to be changed. Okay, that was the point. Now let me finish this with the overall fitting. We are going back to, so the overall purpose is we have just design a data which is looking like say a data with the two categories. We just design this data. Here it is the particular data, and we earlier said that the linear model is not looking good for this particular one. So we are going with modeling. So this is particular sigmoid function, or we can say this is a sigmoid function for 3D plotting or 3-dimensional or 3-variable, whatever you think is good. And now lastly we are going to finalize this particular section. We will say fitting, a logistic regression fitting. This is particularly a logistic regression fitting. We are going with this. Okay, so the point is this kind of function, this particular function is available in our software. On the behalf of that we can go further, or directly we can find out the values of coefficient or values those A and B. So here actually we have two variables. Of course the first one is if you want to say the first one is platelets counts in some way, and the second one is the corresponding value of say response variable 1 and 0. So let me try to find out this. Yes, Anshuman.
Sir, in my 3D picture, I got a plate black not line structure, line type structure.
There may be two issues. Either you just consider the sequence is very small, sequence difference is very small. We are considering, if you just considering this 1 or 0.1 or 0.01, but the overall shape will be look like S in my way. Is it different from
yeah, one instead of one instead of one he taken 0.1, I think, because I have to take also same thing.
If you just consider edge small, the point is edge
0.1 as
point is, if you will increase the sequence, if you just try to I will say visualize the things for each value of x for each value of x2, the second variable, it has to calculate the outer function or the function value of the function. Okay, so as many number of observation in one sequence will be defined, the computation will be that much large. So just our purpose was to visualize how this S function will be look like. So you can take just few value, 10, 20 values within that sequence. Otherwise your system say must be a good capacity to calculate computation capacity. Either your hard disk kind of thing should be a little better. Okay. Now let's come to the point. We are trying to finalize this. Good. We're just trying to finalize this. The point is, say we just define M1. We define our model. The model is comes under the generalized linear model. The command is GLM command is already there, and we are interested to plot or to fit a model between. If we will say the report, or you can take their name accordingly, or report infection versus say report, that's what we are trying to fit, versus say platelets. Okay, so this is our fitting data is of course your report data. Data is your report, you can consider this. Okay, so M2 is our GLM function. I think it will be quite, say in some way, may look like a little different. That this function, this is a line, of course we can say it is linear, but in some way this S function V is a linear model. Okay, this GLM function, GLM stands for generalized linear model. So it is generalized, but even though it is linear model, so it is not avoiding or different from the linear models. But the point is, if you want to see the structure, we can say sometimes it is, but it is a curve. How it can be linear? So in general, if you have in the last section or last lecture, they have defined the kind of linearity. We are just saying that it is linear in parameters. So the parameters in this complete format is in additional format. Okay, and they are accordingly define the parameters. So that's why we are saying, or we can just go with the log transformation, then we can define this. Okay, but the point is we are using the GLM function here, and there are so many. You can go with the summary of this. Maybe summary will be look like summary of M2. Sorry. Okay, one more thing is remaining here. The family we did not define actually. The family, better we just define family, it will provide the better binomial. Okay, you are considering the case with 0, 1 is kind of binomial or logic family. Okay, this is your function M2, and now you can find the summary. There are so many variables defined over there. Z value is a little higher side, 0.4. This will depend up to the data. You can change the data or seed accordingly, it will change. We are just taking artificial data, then there may be some issues. You can go with different observations. I'm not saying, or different values of this. You can go with x1, x2, x2, and then this is your complete data, and then so you can pick model and summary. So these values will be changed as per the observations. Observations are actually artificially generated, so there may be sometimes it look like something different, but overall the point is what we are calculating. There are, as I think earlier you had just used the LM model, almost all the things, all the outputs are belongs to the deviance you are calculating, coefficients you are calculating. One coefficient is associated with the intercept, one coefficient is associated with the platelet. So this is like A and this is like B1, okay, or B, because we have just one variable, so it is like B1. Okay, all things are clear. One important thing which we can see in this, there are many other outputs we can call on the behalf of a particular commands or syntax like coefficient, like correlation, and so many things. But the one of the important thing is this AIC. Okay, AIC is kite information criteria. There are a number of criteria. On the behalf of that, we just compare two models. Which one is better than the previous one or the another one? So of course, negative likelihood, yeah, minus log likelihood is one of that. AIC is one of them. Sometimes we just calculate on the behalf of deviance. Sometimes we just go with AIC and BIC. But the advantage with AIC, this has the values as per the data and as per the associated parameters. Okay, so if we increase the parameters in this model, then there will be some kind of penalty. So AIC will be increased or decreased accordingly. So the overall point is in which we are interested. I'm not going to discuss many things as we are considering as artificial data. The point is, once you can easily get, if we'll say A1 is equal to nothing else, the coefficient of this M2, coefficient, say this is A1, you can call directly, or we can go say this. You can directly use this, or we can particularly define this. So these are the values of A1, and accordingly say B1. So A1 and A2 are the coefficients you can call directly. And as per the overall purpose is this model, is this with the help of this estimated value, can the fitted line of the function, S function, is somehow suitable for this particular data or no? That is our overall function. So in this case also, I'm just using the simple line function. I'm not using predict or any other function. So we can see what is happening all over. The thing is, say range is somehow, again, say, I don't know, X naught is equal to, we are generating a sequence from say 10 to 200 with the difference of say 10. So say this is X naught, sorry, X naught. So we generated this. No issue. Now what we are interested to plot this function. If actually it is well known for us, the function is already defined, so we can go with that, or we can particularly define this for this function. Say we are using f dot say m1 is equal to, if we are just fitted one, then this will be 1 upon again 1 plus. I'm just trying to keep this simple. We are not mixing all those things. So this is exponential. Our function is minus of what? The A1, the fitted value, and plus B1 into the values of X naught, different values on the x-axis. X naught is simply this 10, 20, 30, 50, all those values we are considering as a values of, if we will say, the count, platelets count. Okay, so this model, what this model give at the 10, so we are expecting it will give 0, and 20 it will give 0, and then accordingly there will be some values of this. So we just define this. Now let me draw a line on the behalf of this X naught and this f dot m1 model. M1, okay. So m2 is this. We define this as m2. Okay, so m2 is this. Okay, so here is the model that we have just approached towards this. You can, so I'm particularly by choice, I just do this. We just give a particular line for this particular model. So what it is, the model we assumed, as per that model, what we are doing, we are calculating the value of the coefficients. Once we just calculate the value of coefficient, then for that particular coefficient, for particular values, what we are calculating, we are predicting. These values are the predicted values of the predicted model. Okay, so the actual data was that, and accordingly the values of estimated coefficient, and accordingly this is the fitted model. So this model is somehow, and even though we can say, if you're just interested to find out, so let's make this little bolder so it will look better. LWD is equal to say 3. So this is the line, and you can put a grid which will help you to find out the actual sense of this. So this grid line will somehow justify how this model is able to find out. As we are saying earlier, and we are discussing in between the previous session, then for the smaller values of separated sounds, we are quite sure that that particular person is infected, and for large values of say above 120, it is quite sure that it is almost 1. This model is also giving 1, and that is the value that we are sure that he is not infected. But in between of this, there are possibilities, there are chances with some probabilities which we are defining. So in that case, actual point is, so here I think to write this is infection is not a good thing. What I'm saying that in better of that what I must write, this is not actually the infection, this is the particularly the probability of that, if I'm not wrong. Say here I just put this, and I'm just putting on the y probability of infection. Now it's kind of probability, say probability of infection. So this is your model, then we are putting a line on that, and then it is grid, and then accordingly you can assign the values of this. Say even if you are interested to find out, say I just put AB line also. Deliberately I am doing all these line by line imputation in this graph. See, if you just consider the horizontal line at 0.5 with probability 0.5, so this is the particular line. Okay, so all those values as per this model, all those values which have the count say corresponding to this, say above, say I just say 80 or 90, that belongs to non-infection group, and those are lower than that, that is going with this. Okay, so there are so many things that we can also do with this, not even this. Say one more aspect we will discuss, or we can calculate some kind of table, how many we just predicted. Lastly, what we have predicted, what this model is predicted. This model is predicted that a particular person is infected or not. Okay, lastly, your response variable will give 1 or 0. So you can say in simple, accordingly, if I just try to understand this, if I just say, if else, I just using a particular command, if else, this particular function, f dot m2, or I have to calculate that particular values less than 0.5 for those number which is less than 0.5. So it will take values 1, otherwise it will take value 0. It will 1 if it is greater than 0.5. It will take value 1, otherwise it will take, but it will be particularly defined for those values which are observed earlier. Okay. So in this particular case, in that way we can find out the values of M2, because we just define a sequence on our choice. Okay, so first value is 10, then 20, 30, 40, 50, 60, and up to 70. Up to 70, in this particular case, up to 70, it will giving us the value 0, and all those observations, those are above 70, then it will provide value 1. If you just increase that sequence, a sequence we just define here, say if we consider the 1, then this can also be increased. Here it will be more smoother graph, and at the same time your if else will provide that kind of observation. So now particularly say up to this particular point it is providing 0, and then after it is providing 1. So you can accordingly get the values. I think this will be clear to all. Is it clear what I'm trying to convey?
So kindly repeat once plotting. Plotting point, sir. Sir, I'm not getting that plot.
This particular plot. Okay. The point is, once we are just, this is our actual data. Okay. This is plot for the actual data. Say either you are just generating by yourself, or you have considered the data from somewhere, a real life situation. Now, thing is, what you have done above, you just find out what you have done above, that you just fit the model. I think there is nothing special to specify, that you find out that there are two coefficients in that model, say A and B, either beta naught or beta 1, in what way you have just read that model. So you just find out the estimated value of that point. Now what in which we are interested, we just interested to plot this model, this fitted model, either you can go with the predict function command available in R. We are just simply, that's why I'm just take the observation so we can see what we are doing. The point is we just consider X naught. X naught is nothing else, a sequence from 10 to 200. So 10 to 200 counts on this x-axis. If you see my cursor, so here we are just marking from 10, 20, 30, 40, 50, then 60, 70 to 100, then 100 to 150, and so on. So here we just consider a sequence X naught, and corresponding to those values of X naught, we find out what will be the predicted value by using the parameter A1 and B1. Those are the estimated parameter. Okay, so if we just put those estimated parameters in a model, then accordingly we will get the predicted value as per the values of X naught. X naught is our sequence from, say, from 10 to 200. Okay, the range we are expecting for our data. So you just find out those values. So now what we are doing on this plot, we are plotting the line. This line is nothing else the fitted line, the predicted line. This particular line which we have generated by ourselves, this is simply predicted line. So X naught are your observations. F dot M2 is the function form you just define here to find out the predicted value. So once you just plot this line, so this line is somehow showing that how this model is fitting this particular model and this particular data. So point is there are infinite number of choices of S-shape curve on this data. The particular one, which one is the best, that is look like this with the values of the estimated value of A and B. And I think it is clear, Anshuman?
Sir, actually I'm getting a line, not a sigmoid function. Why I'm not getting sigmoid function in my graph?
Just check. I think it is quite simpler. We are using this functional form only to define this. Either you just consider the F dot M1 or M2. You just check that. Check the function you define particularly. If it is F dot M2, I think I just changed F dot M1. It's a typo mistake from my side. I think you are going with the same. You just check your function is exactly defined that way or not.
But it is same in the equation.
Things are same, then output must also be same. I think there will be some typo mistake. Okay, you can cross check that. So the point is this line is nothing else, just simply the fitting line of that model. We can say with the help of the grid, we can putting an AB line. What we are saying, this AB line is simply, my point is the probability. Probability in the sense of that what is the probability that a particular function, probability of getting more than 0.5 as 0.5 by in fifth self. Are we having probability of infection as well? Sorry, I did not get your point one more time. Shah's Patel's, by giving it, if else are we having probability of infection? No, we are trying to categorize the thing. We are trying to categorize the thing which values have probability more than 0.5 of getting infection and which will have the probability of less than 0.5. The point is your data is actually, your Y response variable is defined simply in the form of 0 and 1. And for that kind of data, dichotomous data, categorical data, you are using a S-shape function. This S-shape function is used because it is somehow trying to capture this structure. But even though it is a continuous function, okay, but that's why it is also taking the values in between that. So how we will justify a value which is say near say 70 or near 200? So what we will say, it is defining a infected person or a non-infected person. In that case, we will define, say it is a defining person with this probability. That much probability belongs to this particular point, and that much probability to going to the other particular one. Okay, so if we are going with the one as a non-infected, the probability that a person with 0.2 is non-infected is still there. There are some such chances. You can see there are two observations here. For these two observations, those are with say number 60 or 70 with counts, but those are non-infective. So there is the possibility. So that's why this function is considering that kind of shape in between the interval. So that's why we are not 100% sure or 100% certain about anyone. We are just going with terms of probability. That's why I just changed this y-axis as a probability of infection. or node infection. So in this case, this is simply probability of non-infection. Okay, so probability of say this or that, which will particularly you interested to calculate at that value of that value, just give the value of AB line, say vertically. Say if you are interested to find out what will be if V is equal to 100, if you just go with that, it will add a line V is equal to 100. The probability is around 0.9. Probability of not infected at with probability plate counts 100 is around 0.9. So in that kind of cases, we generally go with the odd ratio. So there are so many things to check this data is fitting or not and what our model is saying. But overall, the thing is what we are defining, if you will see in our model, that your model is X naught is depending with beta 1. So this beta 1 function, the value of this B1 is somehow justifying with this 0.09. With that kind of rate you are increasing with over the number of counts, and counts is yours in thousands. Okay, so that is the overall purpose we are trying to utilize, or we are trying to establish in this logistic regressions. The overall thing is key, what kind of data we have, and if we just generate our data by ourselves, then we can go with the plotting. But before that, we need a function that is good for that 0-1 response, and then we are further going with the say, if we will say the sigmoid function, which is one of the best choice, and we just consider that for our fitting point of view, just find the estimates with the help of simply the GLM function. It gives the coefficients and all other respected values or output which can be considered, like so simply AIC model fitting criteria and many more. So on the behalf of that, we can check is this that model is good fit for our data or not. So that is I think overall thing in logistic regression. And if we will say there are also a lot of things to say in this. Let me a window. If we are saying logistic regression. Okay, we are just doing calculating with this. The point is what we have done, and we are very short of time. The thing is what we have done half of the work in case of logistic regression. 2-3 more things we can define here, like your function or expected y, or sometimes we say fx is defined is nothing else 1 upon 1 plus exponential of what we define here is kind of a minus b1 x1. So what we are saying, if it is multivariate case, in that case this function will be defined like 1 plus e to the power minus a minus b1 x1 minus b2 x2. Okay, and so on. So you can go with say minus bk xk. Okay, x is your independent variable, and accordingly you are just approaching or you generalizing your experiment. What we have said in the case of sigmoid function, if we are bounding this up to x2, so in this case it is a 3-dimensional picture we have shown, and it will be fit in that way in the 3D plot, and it will be a plot of S function plot. Okay, plane actually. So accordingly you can generalize this thing. One more thing, I just give a little if we'll say idea about that. The point is we just divide this whole data in 2 categories. Either we say category 1 and category 2. Actually we are saying all the time it is a dichotomous thing, so we are saying say it may be 0 and it may be 1, but sometimes it is not necessary. Then the whole data is divided in only 2 categories, either 0 or 1. It may be divided in more than 2 categories. Say like this. Say there are p different category, and we are saying say up to p minus 1. Okay, one category is 0, then 1 to p minus 1. Say we are saying the infected and non-infected, but we can also divide that a severe infected or say moderate or not infected. We can categorize 2-3 different ways. So in that case, your function will be defined accordingly. So it is 12:20 already. So we just had 20-30 minutes. So we are just going with nonlinear regression. Even though we have 2-3 minutes, if you have any doubt in the previous whole section or session, you may ask. Anyone, if have any doubt, Otherwise, we will go with the non-linear regression within 20-30 minutes.
Is there any assumption about the distribution of Y? Like binomial,
of course it is
binomial, because GLM assumes binomial distribution or Poisson in terms of the dependent variable.
Yes, of course.
But here there is fitting of some kind of deterministic model is done.
The point is that here, if we'll see, actually, I just try to skip the mathematical format of all these things deliberately. The persons belongs to different group, but overall, the point is, if we'll just finish this within one slide, what we are considering is, say, y is equal to, if we will say, is a function of form like this overall, okay? And we are saying, say, this y, the basic function is it is taking 0 and y value. So of course, if you just define the overall, what we are trying to do, we are just trying to, yeah, of course, Manju, I will just justify this. The point is, the overall purpose is what? We are just purpose to calculate the values of beta naught and beta 1. In that case, we need the functional form, the probability of that, okay? So what we say, it will take the probability with some observations with going with pxi and to be, say, 1, and with other with 1 minus pxi, okay, with some value 0. So the point is the overall we are going with the binary distribution in this case, or just as we consider binomial family. The overall thing is defined on the basis of this, say 0 to 1. So if it is considering from this case, so we are simply going with this. That's why we are considering the logit function in the overall whole things. And at the same time, one more thing I think which is important is log of y minus. There is.
Okay,
yes.
Okay, thank you. Thank you.
Okay, so we are going with this pxi. At the same time, I just give one more second to define this. Of course, we are going with the distribution. For the point is, log of this is also
that logit function. I understand that logit function. Thank you.
Not for you particularly. I mean, in general, just saying that one more thing which is important there. Important is this is the probability of xi is whole is divided by 1 minus probability of xi. The meaning of that is quite important. The probability of this xi is defining, say, the value of y as per what it will be. The point is the person is, I will say, is not infected, and with what probability divided by for a particular value of xi, and whole is divided by 1 minus pxi. Okay, so this is the probability of infected. In some cases, it may be like 3 by 1, we will say. For this particular, after all calculations, not in terms of probability, after calculation, we're just getting as 3.1. For this particular value of xi, that maybe there are 3% kind of things we will say. There are 3% which are not infected, but 1% is possibility that it is infected. Those are the cases we are taking within that limit. Okay, so we cannot guarantee all the time the 100% it will be, certainly it will not infected or infected. We are going with kind of chances, and that's why we are defining sometime odds. And on the behalf of odds, sometime we are trying to find out the estimated values of odds as per your fitted value. Okay, so in many terms or in many study, in place of just defining the beta naught beta 1, we talk about in terms of odds. Of course, if you will say there are 4 persons and 4 patients with the, say, 100 as a platelets counts. So what we can say, out of 4, 3 persons may be not infected and 1 person may be infected. So that kind of a study in general works in the real life situations, or maybe some medical persons used to talk in that terms of odds, in terms of, not in terms of A or B, estimated L4, L5, beta. Yes, 1, 2, 3 things. Actually, I'm just trying to go to the next topic. If y has 3 categories, how to do we still apply this method even one of the independent variable is category, just like target? Of course, x, you can take x values of x, like what will happen if we consider gender in this as x2. So you can consider gender, say 1 for girl or 1 for female and 0 for male. You can consider that. You can consider like age in that factor. So there is no as such foundation with the x value, number 1. And one thing is, if y has 3 categories, how to do? So if y has 3 categories, in general, what we do, we consider one category as the base category. Okay, say non-infection is the base category. And then one category is say moderate, and one category is severe. Okay, so these are the three categories. So one is base category, and two other categories are considered as a 1 or 2 in like this form. So in that case, our expression will be actually designed in the similar way. In such cases, we just express the things like I just defined somehow here. The category will be defined accordingly. This function will be defined. This function will be function of particular numerator. We consider the particular category, and the denominator will take the whole weight of all categories. So in that way, we define the values. And probability is as such: the y will take value 0, or y will take value 1, or y will take value 2. So in that way, we just interested to calculate. So let me go to the another section, which is non-linear. I think this is enough for this logistic regression. The overall, my purpose was that how we can justify or how we can see that functional form, and on the behalf of that, how we can go further. Okay, the first thing is, if once just we see the logistic function, then we can go as per their characteristics, as per their properties for our model, and then accordingly we can define our model, and how these parameters are changing the overall properties, which we have seen with the changes values of a and b. Good. Now next thing is simply a non-linear model, and I don't know how we will capture this within 10 minutes. So non-linear terms is generally, if you will say, is defined, and of course which are not linear, those are basically are non-linear, and in non-linear terms can also be, say, derived in many ways. So the term is like this: how we can say a functional form is non-linear. So we just take non-linear terms in many studies, and we are considering a particular one actually. The non-linear term is different type of non-linear, if you will say. It may be, if what we have studied very first time is a polynomial. Okay, a polynomial function, a polynomial regression we did. Okay, one thing is. The second may be what we have done, linearization of non-linear. That is one approach. And the last one is, of course, a non-linear regression. So 2-3 different kind of approaches used to deal with this non-linear regression. So of course, polynomial is quite different in some way. And polynomial in the term, when we just say we define a functional form in terms of, say, y is equal to, say, I take the simplest one, say a plus bx plus cx square, and so on. And say some k up to k. Kx is to the power k, like thing. Okay, the point is, here we consider the powers of this, but parameters are in the similar way defined. So if you just try to remember the earlier classes, what we have done, we just make a system of equation, and then we just keep those in the matrix format and calculate all the values of that. But here, what we are trying to do, we are just defining a non-linear equation. So of course, if your pattern is somehow look like in that format of your data, in which you are interested to somehow fit. So let me design, then we will make the things as we have done earlier. Let me design a data which is somehow non-linear, and then accordingly we will go with that. Okay. Sure. Let me define. Is it good? So we can consider, the point is, as earlier we just cooked a data, or we just artificially design a data. Here also we are not going with a particular realized example. We are just going with a simple plot which we are just creating. Say if we have, you can just set a seed. We're just setting a seed in first like this. So you can take any value of your choice. Then we're just defining, say x is a sequence, as we considered earlier. We can say 1 to 50 is a sequence with a difference of 50, and there is no issue at all. Then we are defining y. You can define any if we will say any functional form which you look like that, that is not in form of linear, say a standard format, we just say you can take any value of your choice. So n into x whole is divided by say 10 plus x. I'm just defining a model. Okay, so for each value of x, if you will say what I'm trying to show you, that there is a x, there is a y. So we just set the seed, we have x, we have y, and accordingly we have the plot of this. You can set a parameter here. Let's see. So here is the plot. Of course, somehow it is looking like a monotonically increasing format with this functional form. Okay, the point is what we are trying to do, what if we just add, look, we are just trying to create a data which is look like nonlinear data, and then accordingly we try to find out a functional form and then estimate the values of parameters. That is the overall purpose of this. So what we have done, let we add some kind of, we just say error. Okay, so error is some nothing else, we just add 15 observation with some 0 and 1. Okay, with corresponding to each value of x, we are corresponding to each value. What will be the change as per this additional? The things will be look like this. If you will see what it has done, say overall, if we are assuming that data is following a particular functional form, doesn't matter it's linear or non-linear, that means that forms will be exactly defined. But then we will say there is some error terms or that some errors are possibly introduced in that data. So that error we have introduced here, and accordingly the well-defined earlier plot is changed to that kind of particular plot. Okay, earlier the observation was this, now these observations are somehow this. But even though in some way we can say this is particularly capturing this particular format, as per you change the seed, accordingly the plot will also will change. Okay, you will create observations as per your R norm, and then accordingly those error terms will be maybe some plus or minus, then accordingly your observation will be slightly changed. So this is the functional form. This is the data in some way we'll say. And of course, if you will try to fit a line with those particular values of x and y, which we are taking, say with the values of x, and you plot this particular function, is the exactly known function which we have. So this is the line, fitting line. So overall, if we say in which we are interested to find out this line. I'm not wrong that we have a data. Our data is this, and for this data we are interested to find out a line. The actual thing is, actually when you have data, you have the values of x and y, so you have no idea about this function. But here, because we are just generating the thing, so we exactly know the functional form. So the best possible fit for this is one of this, as per this. Actually we know that the floating form is this. Now the point is, but because if it is unknown, so we have to find out some, say, methodology, or with the help of that we are going with this. So say we are considering a model M3, and we are using, there are a number of different commands or different packages available for non-linear modeling. The one of them, the simplest one, is say NLS. Okay, it's behalf of the least square estimation, and in this we are saying we are trying to fit a model by, and say now the situation is we are not sure about the value of the parameters in this case. So a model we are interested to fit, and in this model we have, here we just take the exact value 9 and 10, but actually we have no idea about that. We are just trying to find out a functional form which may be suitable. Like in the previous case, we find out a sigmoid. Here we just found a functional form, maybe a into x and b plus s. As per the functional form, say sometime it will be exponential, maybe better go fit. Sometime it may be, say, logarithmic scale is maybe better go fit. But in case, say, we are considering, say, the equation is, say, a into x divided by b plus x, and but a and b are unknown. So we are expecting from our model, through this analysis, that somehow it will give us the value of value of A and B. And somehow means by converging this to the particular data. So if you will run this, of course, sometime it gives a warning message to you. It is expecting a starting value from your side. Otherwise, it will be calculated. If you will say, okay, first let me check what it has done. The summary of this model M3 is here. And what it has done, it just find out everything is looking good. The value is 8.7 and 9.8. The coefficient of this, if I just talk about the coefficient of this model, the values of coefficients are coefficients. The values of the coefficients can be find out, or estimates can be find out directly. Or parameters, the command I have here. And this on behalf of this, change this parameters. The value, okay, let me this. So here A1 is nothing else, simply 8.79 like thing, 8. I'm just storing by default, and B1 is nothing else in 9.8. So these are the values on the basis of, say, this case, when in all the time once you will run that, it will provide a non-starting value. So better if you just put a starting value to get the convergence as earliest as possible. So you can visualize the things and accordingly you can find out, or you can just give by default. So it is simply the start value where it is expecting to start. You just give the list of your parameters. Say you are considering two parameters. So you are considering two parameters. Say A is equal to, you can give any value. Of course, it will be good if it will be near to that, say 11. Okay. So we consider this. So value of this parameter. So you can go with that. Then this error warning term will be removed. And even though after, once you just find out the summary, why I'm trying to find out this, there is no as such change with the value of the coefficients. The only thing, sometimes if your data is large, if your data is mixing is at the high level, then number of iteration to find out the estimate may be increased. But overall, it is expected that the coefficients value will be almost similar. Okay, there will be no as a bigger change which will define or predict the observations. Now the point is, if your plot was this, then if these two things are good, or these two estimates are good coefficient for your data, of course it is near to that. So what we are doing, in place of this we are considering A1, and in place of this we are considering, say, this B1. So X is your values for XY, A1 into X is your sequence. Yes, this is the line. So this is look like almost the same, but it is different from the previous one. The previous one, which is your actual line, it may be different from that. So there is a little deviation from that line as per the data. So this particular line is the actual line. This particular line is the actual, from which your actual function. This is the actual function which belongs to your data. But even though, because you are considering the different state, so in case data will be associated with different normal values, at the same time your plot will be different. The corresponding actual line is this, but once you just fit your model with some estimated values, it will consider the randomness of the data, and then last it will provide the line. So red one is your fitted line. So this is how your observations maybe differ from that. From the actual things, because of this. Even though if you are just interested to make this better fit, if you just you maybe down this, or there is one another way, if I'm right to think, you can define this function one much better way. In place of particular fixed value, you can give a particular value of unif r function, say 1, or you can take the value, any value of your choice, say 10 to 20, and accordingly you are just making some randomness in this coefficients value also, which we are fixing earlier. But here you have changed those values also, say some values from 0 to 10. The first thing is I'm just plotting port as well as, okay. So now your data y1 is say this, y1 will be this, and if you plot, what is doing, then in artificial data we are considering a particular value of a and b. What we have done here, we just take some randomness in that observations also. Okay, so what will happen now, your plot of this x and y1 will be like this. So you can change this plot if it is scattered or so many things, then accordingly you can change these values. If you consider 5 to 20, then this is looking more smoother than the previous one. So this is your plotted values. Still you are not aware about the actual values of this. And now if you fit kind of this actual, then it can be completely different from that. So there is no meaning of this line right now because we are just shifting these values. So now we have no idea where these A or B coming from. These are generating randomly. As per the values of our uniform, these values will also will change. So overall, we have this particular plot. Now, if you are going with this model where A and B are completely unknown, even we don't have any idea about this. Now, this start function may become into role. If you choose a good one, then accordingly it will find out. And if it is poor, then it will be take one more iterations in that case. But at the same time, your summary will be like this. Sorry, here is the values of your parameters. So in that case, there are some little shifting in this, say 8.4 and 7.7 in this case. And even though if you just define this, again, your line will be, I think, 8.4 and 7.7. So these are the new value of your V1, and your line will be fit like this. It is a poor fitting, not as good as we are expecting. Okay. So this is the functional form for non-linear format. So these are the things which we can say, I think, consider or conclude in this session. And I have also a meeting from 1 o'clock. So if you have any other queries, we can summarize the things within 5 minutes. So these are the point functions. One more thing I will just try to convey here. Once we are using this least square procedure, so I will advise you just at least once you just visit and see what is the least square method. And of course, what it is and what is the need of once the Legendre, I think in 1800, around 1800 generated this, developed this actually. So what was the purpose to find out? There is a interesting story to give this method. How we just particularly find out that out of infinite lines, one particular line is the best fit. So least square gives you the best fit line, and out of choice of hundreds of lines or thousands or infinite of lines. So you just Google or search what is the least square method, who developed this and why he developed this. There is some conditions or he's working some problem associated with the peripheral of the earth. He was just calculating to that. And then he just find out the methodology of the least square, and then it used widely in all over the mathematics and physics and all other subjects. So you just try to read that least square methods, and we also utilize the analysis function in case of this non-linear programming. So as per you consider a data, you just find out one of the model, and accordingly you find out the coefficients. Okay. So if you have any query, you may ask anyone. So this is from my side, how can you get the idea about function from geometry of data. Yeah, the same thing what I just said in the previous time when I was saying that all the time it is important to find out the geometry or the function. Just how we just find out why sigmoid is a good fit for that particular data. So in all the cases, once you have a data, once you have a data, you have to go with the particular functional form. So of course we have some idea. We must have some idea about about that. Then accordingly we will go. Okay. Yes. The good book, if you will say in general, we just follow. I think there is a book of D.C. Montgomery, simply named as the Introduction to Linear Regression Analysis. One book is of Draper and Smith, Applied Regression Analysis, but those all books are particularly for statistics persons. Okay, and if you are not belongs to particular stream, you are using statistics, but you belongs to a non-statistician subject format. So in that case, there are a number of lectures and all things are available. But I think Montgomery and Draper are both books with have number of examples actually. So person who just read himself or herself, that book, both books are good. Otherwise, Yen Jia book is good. Linear regression analysis. Good. Anyone else? Okay.
So there are a few participants who are asking for good books on linear regression, non-linear regression. Sorry.
Not particular. I think if you will just go non-linear regression books, I think this I will not suggest in that way. I will just suggest if you are in the first way, one of book. I just ask 1 second. Let me see. There is a book of applied regression analysis and other multivariate methods. This is a we generally say it is a Cooper book. Okay, this is one of the best book, but in that case you have to have a thorough knowledge of mathematics as well as for the statistics. So if you are non-statistician background, you just go with the Montgomery and Draper, and if you have good knowledge or better knowledge of mathematics, then you can go with the Cooper and Muller book, applied regression analysis. Okay, all the 2-3 books are, I think, good enough. The point is those are with full of examples. Yes, the instant R unif part in last area. Yeah, in last case when we are just considering the R unif, actually what we are trying to do, we are trying to make a kind of mask to ourselves, like things in earlier when we are considering this A and B area. In last case when we consider this 9 and 10, then we exactly know what is the value of A and B. So to make this more complicated or more, say, to hide from ourselves, what we have done, we just consider the value of R unif. So we are generating one number from a sample of 5 to 20 and one number from 0 to 10. So in that case, we are unknown about the values of A and B. So when we are generating from that data, then these value A and B can be, estimated value can also be changed accordingly. So we cannot fix with them. So the sample observations will change, will influence actually at the value of A and B. R unif with 1, and this is nothing else, simply one value from generated from the uniform distribution. So earlier we just considered this 9. Now we are considering this as a 14. Okay, and this R unif, which is earlier we considered 10 at the value of B. Now we are considering the 9.8. So what we are trying to do, we are trying to make kind of mask that even we don't know what is the value of N, and then we are going to estimate that. Okay, Darya?
ओके सर देन फिर ये एनालिस में सर सेम फंक्शन यूज हुआ है, जैसे कि M3 में y1 को ax1 कर सकते थे ना, कि क्यों मतलब M3 तो 3 में सर वही चीज क्यों मतलब एनालिस की गई है सर? ये M3 फिर किया गया है ना एनालिस नॉन लीनियर, इसमें नॉन लीस्ट स्क्वायर लगाया गया है फिर y को ax से, बट अगर इफ हम लोग R यूनिफ ले रहे हैं तो y1 को हम लोगों को रिग्रेस करना चाहिए था ना, कि y ही किया गया है लास्ट 16 पे।
हाँ, ये y1 को हम कर सकते हैं, ऑफ कोर्स y1 के साथ जाना चाहिए, ऑफ कोर्स y1 के साथ जाना, ये मिस हुआ
बिकॉज सर वो वैल्यू सेम आ रही थी ना, फिर से 8.59 और 9.86 ही आ रही थी।
ओके